Welcome to Casa Academy Chapter 16, Part 2, where we will cover real estate appraisal. We are going to get straight to work on mastering a critical concept for your exam today.
This explainer is all about equipping you with the appraiser's ultimate tool, the Cost Depreciation Approach. We are building a really solid foundation of knowledge here because this specific approach is exactly what appraisers use to estimate value when comparable sales just aren't available. When the normal rules don't apply, this is the specialized go-to method they turn to.
Okay, let's dive into this. Our journey today covers 6 clear stages to help structure your studying: cost depreciation basics, types of depreciation, estimating construction costs, accrued depreciation methods, the valuation steps, and finally, a chapter summary.
Section 1. Cost Depreciation Basics. Valuing the unique. Now, this whole approach hinges on the principle of substitution. Think about it. A rational buyer simply won't pay more for a property than the cost to go out and build a similar substitute.
Because of that principle, this approach is the absolute go-to for special-purpose properties. Think about churches, schools, or government buildings. They don't exactly sell every day on the open market, so we really can't compare them to standard house sales. It's also perfect for estimating insurance values, evaluating brand newly built properties, or looking at properties with proposed renovations.
Moving right along to Section 2, Types of Depreciation, Understanding Value Loss. Before we can do any math and actually calculate values, we must fundamentally understand what makes a building lose its value over time. So the crucial point here is understanding these 3 distinct categories of depreciation. First, you have physical deterioration. That's exactly what it sounds like: basic aging, normal wear and tear, peeling paint over the years. Then there's functional obsolescence. Imagine a massive 4-bedroom house, but it only has one tiny bathroom. That's an outdated, functional design the market simply won't pay for. Finally, external obsolescence. This one is super unique because it's caused by factors completely outside the property lines, like a noisy new highway being built next door, nearby industrial land uses, or even broader economic downturns.
Now let's tackle Section 3, Estimating Construction Costs, Building from the Ground Up. It is time to figure out exactly how much a building costs to construct in today's market before we subtract that depreciation.
What's really interesting about this slide is how incredibly easy these 2 specific terms are to confuse on the exam, so pay close attention to the distinction. Replacement cost is all about building a modern equivalent. You're using modern materials, modern design, and modern construction methods to get a building with a similar utility. Reproduction cost, on the other hand, is much stricter. It means building a perfect, exact replica of the original structure. We are talking about using the exact same materials, exact same design, and exact same layout, but doing so at current market prices. To figure out those construction costs, an appraiser is going to use one of 3 methods. The quantity survey method is the most detailed and accurate, calculating the cost of every individual component, material, and labor hour needed, but naturally it takes forever. The unit-in-place method speeds things up by using published cost manuals to price out entire building components, like all the roofing or concrete work at once, which makes it faster while keeping reasonable accuracy. By the way, your verification code is 154777. Lastly, we have the unit of comparison method. This estimates the cost based on a known cost per square foot or cubic foot. It's the quickest and easiest method, making it super popular. An appraiser might use this very method to quickly estimate a building's replacement cost based on current local construction averages.
Next up is Section 4, Accrued Depreciation Methods, Calculating the Where. We have our construction cost estimated, but now we pivot to the next logical stage: calculating exactly how much of that brand new construction value has accrued or basically accumulated in depreciation over time.
This brings us to a simple but highly testable formula, the economic age-life method. You simply divide a building's effective age by its total economic life. Economic life is just the total period the building actually contributes value. But here is the absolutely critical distinction for your notes. Effective age is not necessarily the building's actual, chronological age. Instead, it reflects the age the property appears to be based purely on its current condition. So, if a building looks to be 20 years old and has an estimated economic life of 40 years, you just divide 20 by 40 and the building is considered 50% depreciated. You then simply multiply that rate by the replacement or reproduction cost.
Section 5, the valuation steps, the appraiser's process. Let's move to this and see how this builds, combining everything we've just learned into a strict, step-by-step mathematical sequence.
Here are the 6 critical steps an appraiser walks through sequentially. Step 1.
Estimate the site value. I really need to anchor you to this fact right now. Land does not depreciate. Because land has an indefinite life, its value must be estimated completely separately, as if it were vacant land, right there in Step 1. Then, in Step 2, we estimate the cost of the improvements. Step 3, estimate the accrued depreciation on those improvements. Step 4 is just simple subtraction. Take the cost from Step 2, subtract the depreciation from Step 3, and that gives you your depreciated building value. Step 5 involves estimating the value of any site improvements, things like driveways, fencing, or landscaping, and deducting any applicable depreciation from them as well. And finally, Step 6 is calculating the final property value.
Finally, Section 6, Chapter Summary, putting it all together. Let's transition into our final recap to synthesize these highly technical concepts into an easily memorable final exam takeaway.
And this brilliantly illustrates exactly what happens in that crucial final step of the valuation process. Step 6 finally takes that independent vacant land value from Step 1, which, again, never depreciates, and adds it back to the depreciated building value, plus the depreciated site improvements. Adding those three individual components together produces the ultimate estimated value of the property under the cost depreciation approach. It's like putting together the final pieces of a puzzle.
To wrap up this explainer, I want to leave you with a provocative question to really test your grasp of these concepts. If land itself never depreciates, how might a sudden case of severe external obsolescence in the neighborhood uniquely impact the overall final value of a property? Think deeply about the relationship between the permanence of the land's value and those external depreciation factors existing entirely outside the property lines. Master the interplay between those elements, and you will be completely ready to conquer this section of the exam. Keep studying hard.